Excellent.
Just a second. Yeah. Okay, hello everyone. I will be presenting the X-ray photoelectron spectroscopy today. Here's the presentation outline. We will do the little introduction, then some example, and then some details about the XPA's manufacturer and specification, and then finally the summary of all. So what is XPS is a stand or like a shortcut for X-ray photoelectron spectroscopy. It's a surface sensitive tools based on the photoelectrical effect. And here is the symbol diagram of component of the XPS. Here we have electron gun that, just a second. Yes, that shines some electrons into the aluminum anode, and then it will goes to the quartz crystal monochromatic, and then finally this chromatic will focus the X-ray beam, goes to our sample. Our sample will inject or release these photoelectron rays, goes into the energy analyzer, and then finally to our computer. And here is the typical spectrum that we will see, showing the binding energy in electron volt and the intensity corresponding to each peak that we have. So basically, XPS only will show us the element that we have in our sample. It will show us the elemental composition, the empirical formula, we can also calculate it, and then the binding energy of each element and the chemical state. So how it works, or the theory behind it, based on the photoelectrical effect discovered by Einstein. So here we have the core energy levels of the electrons in the atom, and then here we have the Fermi energy levels separating the conduction band and the valence band, and above that we have the free electron energy level. So first we shine an X-ray with a specific frequency, so it can be able to excite our electron in the core level, and then when it will get excited, it get released, and then release some electrons with photoelectrons with kinetic energy. So here we can call this one as a binding energy, here as a work function, which is different from each element in the periodic table. And then here the kinetic energy, or the extra energy that the electron has to get released. So to find that, we just use this simple equation, and then the device will do all the calculation for you, and you will see the peaks in each position. Here is the periodic table for the most value that we use for each core levels for each atoms or each element. So after that, I'll speak about some application. We can use it in material science and thin film research. Here we have the pure nickel foil after oxidation, and here we can see the chemical state of the oxidation level of the nickel. And after we treat it or cover it with a boron nitride, we do again the XPS, and you can see that this chemical state of the nickel is not there anymore, and can provide this information, or we can have this information by XPS. And also some other application can be also, I have found this interesting paper about the food product, when they can also see some kind of element that they're interested in. And the most important thing, they can find also the concentration of, let's say here they're interested of carbon, mole per gram for each element that they tested here. And finally, the specification and the manufacturer of XPS. So we need high vacuum for XPS 10 to the minus 6 Pascal. The depth, or the X-ray can go to, is 5 nanometer, and the scanning area is 200 micrometer. The measuring time can be from 20 to 4 hours, depending on how much deeper you want. And here we can find some manufacturer, and in Chaos, I have worked with Kratos before. And there's also Thermoscientific as an example. The cost can vary from 250,000 euro up to 1 million euro. And the accuracy of the atomic percentage that we have in our specimen can also be 90 to 95 precise for major peaks that we have in our signal. And for the low peak, we can be precise 60 to 80. Yes, that's all. Thank you all for listening.